Woohoo! Welcome back. Today we're going to be talking about real zeros of polynomials. Real zeros? What does that mean? And the answer is, well, up until now, we've been talking about factoring using integers. So all of the zeros were numbers like 0 or 1 or 12 or negative 13. And so now we're going to start to expand our search for zeros. And you've played with this a little bit because when you use the quadratic formula, frequently you find answers that are either rational numbers, so fractions, or even numbers that have nasty square roots. So they're real numbers. They're irrational. So we're going to start off with looking for rational zeros. Woohoo! Yay! Fractions. So in this case, fractions, which I know a lot of people are like, ugh, fractions. But it turns out that fractions are actually some of the nicer zeros we can go looking for. So we're going to start using this theorem, the Rational Zeros Theorem, to look for these zeros. So we've got our standard polynomial, an x to the n plus an minus 1 times x to the n minus 1 plus a1x plus a naught or a0 has integer coefficients. So we are looking at fractions, but we're not looking at fractions in the polynomial itself. The polynomial needs to have integers. Then every rational zero of p is of the form p over q. And this is a pretty standard setup to have p over q as your rational zero. And here I will write it a little bit bigger. So if you're looking at it a little tiny screen, you can see p over q. And p and q are integers. And here's the exciting part. I know you're very excited. P is a factor of a naught. So the constant coefficient, that's going to go up on top. And q is a factor of an, so that's the leading term coefficient. The coefficient of the leading term is going to go in the denominator. And so let's take a look at an example of this. So what are the possible rational zeros of p of x equals 3x squared minus 3x minus 6? So let's take a look here, and we see that a2, the leading coefficient, is 3. And a naught, the constant coefficient, is negative 6. Okay, so a naught is negative 6. Now, the factors of a naught. So factor, remember, are the things that go into it. So plus or minus 6. What else goes into negative 6? You got it. Sorry about that. Plus or minus 3. What else? What else goes into 6? Plus or minus 2. And then don't forget the trivial. People often forget the ones because, one is, obviously one goes in, but you include it as well. Now, a2, the leading coefficient, is 3. Factors of a2, plus or minus 3. And because 3 is prime, there's only one other one. Yeah, plus or minus 1. So this is the way that I've always written it. It's not mathematically rigorously correct. But what I do is I give myself a long thing, and I'm putting in a little colon there to make it clear that it's not exactly equal to this, because I'm just going to make a list. Now, the thing to remember is that a polynomial for this formula tips up from the back. So a naught is going to go on top, and a2 is going to go in the denominator. So plus or minus 6, plus or minus 3, plus or minus 2, plus or minus 1, and then plus or minus 3, plus or minus 1. So far, so good? So those are all the possible numerators and denominators. So what do we do with this? Well, so then I make a list, and you can go through these however you'd like. There are 4 possibilities on top and 2 on the bottom, which means altogether there are 4 times 2 means 8 possibilities. So I'm going to just start plus or minus 6 over 3, plus or minus 6 over 1. You can see what I'm doing. Plus or minus 3 over 3, plus or minus 3 over 1, plus or minus 2 over 3, plus or minus 2 over 1. Whoops, I'm running out of room. I shouldn't have written that so far down. Here, I'm going to fix it. What? Is that a pterodactyl behind you? Say hi for me. Oh, look out the window. Isn't that lovely? Okay. Plus or minus 2 over 3, plus or minus 2 over 1, and then plus or minus 1 over 3, plus or minus 1 over 1. So those are all 8 possibilities. And of course, it's not really 8. There are 16, because each one could be positive or negative. And a lot of people say, well, don't you have to do plus or minus on top and bottom? And the answer is no, because you can only be positive or negative. So even though there's a plus or minus on top and a plus or minus on the bottom, all together, when you cancel everything out, the whole thing can only be positive or negative. There are only 2 options. Okay, now down below, I'm going to simplify. So 6 over 3 is 2. So plus or minus 2, plus or minus 6, plus or minus 1. I'm just simplifying. Plus or minus 3, plus or minus 2/3. That one doesn't simplify. Plus or minus 2, plus or minus 1/3, and plus or minus 1. Okay. Now, the thing is that, where's my red pen of destiny? Oh, no. Oh, there it is. So, if I circle, for example, plus or minus 2, there's another plus or minus 2 that I'm not going to include in the list. Plus or minus 6, plus or minus 1, plus or minus 3, 2/3. 2 is already listed. 1/3, 1 is already listed. So in fact, I only get 6 possibilities. So it's either plus or minus 2. Let's see. If I do this, can I do this in order? This will be hard to do. I can try it. So there's 1, there's 2, there's 3, there's 6. And oh my goodness, I should have written it further out. I could do 1/3 and 2/3. Now, you may be looking at this going, okay, seems like, I mean, it's not a lot of work. It's just kind of work. But what does this do for us? Well, this tells us that these are the only possible zeros. And in fact, you can use this when you're trying to factor quadratics. If you don't want to use the quadratic formula, this is a quick way to write out all the possibilities so that you could narrow down your options. But now we only have to check 6 possibilities instead of an infinite number of possibilities. Okay, shall we use that? So how are we going to use that? We're going to list all possible zeros, like we just did. Test the zeros using synthetic division. When you find one with a remainder of 0, note the quotient you observed and repeat, starting at 1. Okay? So, if I've got the zeros of this, so first off, my leading coefficient is A4, and that's 1. That's going to make things really easy. And my constant coefficient is going to be 10. Okay. Now, interestingly enough, notice I don't have to worry about any of the numbers in between, which is really interesting, isn't it? Okay, so now you got to remember to flip it up. The last one becomes the top. What do I mean by that? I mean that all the factors of 10 go on top. So plus or minus 10. What else goes into 10? 5, 2, and 1. So I think through all the possible factors, not multiples, factors. Now, since this is 1, all we have is plus or minus 1, which is, oh my gosh, so much easier, right? In the previous problem, we had 3s and 1s, which basically doubles how many possibilities we have. This, we're just going to have 1. So it's going to be plus or minus 10, plus or minus 5, plus or minus 2, plus or minus 1. So now what do we do? Well, what we're going to do is we're going to use synthetic division. So if I've got x to the fourth minus 5x cubed minus 5x squared plus 23x plus 10. Let's see, anybody missing? 4, 3, 2, 1, 0. No, all the terms are there. Then I'm going to use synthetic division, and I have to pick one. And honestly, you can pick whatever number you like. So if you start with 10, I mean, this is basically either you get lucky or you don't. And I go 1, minus 5, 23, and 10. Remember, the 1 comes down. 1 times 10 is 10. 10 minus 5 is 5. 5 times 10 is 50. This is 45. 45, 10, 450. 473. 4730. Nope. And why did I write nope? Well, the answer is that clearly this is not going to cancel out to 0. So this is not a 0. Okay, 10 is out. Okay, negative 10. Now, if you see one that you think is more likely to work out, then you should do that one. Okay, thankfully we just have synthetic division, which is a lot faster. 1 times negative 10, negative 10, negative 15. Negative 15 times negative 10, 150. 145, oh, this is not looking good. Negative 1450. And then this is what? Negative 1427, and this is a big nope. That's not going to work out either. And it is okay to abandon when the numbers get really big and you're pretty sure. Now, if I quit early, it's possible that I'll miss something. So, you know, it depends on how much practice you've had, whether or not you feel comfortable that this isn't going to work out. Let's try something else. Let's try, so the 10s are done, so let me try the 5s. Okay, 5 into 1, negative 5, 23, 10. Bring the 1 down, 1, 5, 0, 0. Ooh, this is looking good. Negative 5, negative 25. Right, and then negative 25, and then this is negative 2. Negative 2 times 5 is negative 10, and oh my goodness, woohoo, we got a 0. So this means that 5 is a 0. Woohoo! And then that also means that x minus 5 is a factor. So that's nice. Now, we've got to try all the rest of these. But I'm not going to go back to the original. I'm going to go to my new polynomial. I've got x minus 5 times, and this is a remainder, so this is constant. This is x squared, and this is x cubed. Remember, they drop down one level, so it's x cubed plus 0x squared minus 5x minus 2. So now I can use this new polynomial and break it down. So look at x cubed plus 0x squared minus 5x minus 2. Now, what are the possibilities we have here? Well, we decided plus or minus 10 don't work. Positive 5 did work, but we haven't tried negative 5. And then we've got the 2's and the 1's. Now here, A3 is 1, and A naught is negative 2. So if we look at our P over Q, remember, A naught goes on top. That's plus or minus 2 or plus or minus 1, right? Those are the numbers that go into negative 2. A cubed is just 1, so we got plus or minus 1. Notice we have eliminated negative 5 as a possibility. It won't work in this one. So we don't even have to try negative 5. Okay, so we got plus or minus 2, plus or minus 1. I'm just going to start with 2, and I'm going to use the new polynomial 1, 0, -5, -2. And let's go 1, 2, 2, 4, -1, -2, -4. It was close, but it didn't work. Right? And I double check. 1, 2, 2, 4, -1, -2. Okay, let's try -2. Okay, 1, -2, -2. -2 times -2 is 4. -1, -1 times -2 is 2. That's 0. Okay, so now we know -2 is a 0. And x plus 2 is a factor. And we've got a new polynomial that we're looking at. And in fact, I'm calling it a new polynomial, but it's not really new. It's just a new form. So maybe I should write that new form of a polynomial. You know what? I even don't like that phrasing. I'm going to change it. New form of the polynomial. Okay, what did we have? We had up here x minus 5. And then we've got right here. I'm sorry, poor Sharktopus is like, hey, I'm smooth and continuous. It's like, yes, you are, sweetie. Okay, x plus 2. And then we've got this polynomial, which is now x squared minus 2x minus 1. So you see that x squared minus 2x minus 1 right there? Okay. Now, what are we left with? We're left with just checking 1 and -1. So let's try those two. So let me try 1 into 1, -2, -1. 1, -1, -1, -2. That did not work. Remember, we're looking for a 0. Let me try -1. 1, -2, -1. My hand is clearly done with this problem. It's like, nope, I'm done. So there is a downside, and that is that you end up using some paper. So feel free to use both pages, you know. Wait, did I make a mistake? -2, 1, -1, -3, 3, 2. No. That's very sad. So now we ask ourselves, what the heck is going on? Because 1 and -1 didn't work. So let's look at x squared minus 2x minus 1. So if we set it equal to 0, we can use the quadratic formula. So it's the opposite of -2 plus or minus radical -2 squared minus 4 times a times c all over 2 times a. Okay, so that's going to be 2 plus or minus, let's see, inside, that's 4 plus 4. Oh, I see what's happening. Do you guys see what's happening? 2 plus or minus radical 8 all over 2. So this is irrational. And here's the problem with this technique. This technique that we were introduced to over here is called the Rational Zeros Theorem. So it'll give us all the rational zeros, but it won't give us the irrational zeros. We have to find those ourselves. Okay, so bare math, radical 8 equals 4 times 2 inside, right? So the 4 is really just 2 2s, so we got 3 2s running around. 2 2s go running out of the cabin. Yum, 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 yum. And there's a 2 outside and a 2 inside. I factor out the 2. I cancel the 2's, and I get, oops, 1 plus or minus radical 2. So what are all of our answers? Okay, answers. Rational zeros were, what were they? Let's look through. What ones did we find? We found 5. Yes, yay. We found negative 2. So we found 5 and negative 2. And then irrational, which the problem doesn't ask us for, but I thought let's just do it. We were so close. 1 plus radical 2, 1 minus radical 2. There you go. And so what have we done? We've completely factored. Well, we haven't written it out, but we've got all of the zeros. So we know all the factors of this polynomial. And that will help us graph and determine the rest of the behavior of the polynomial. Yay! Okay. In the next videos, we're going to learn a couple more of these little tricks for finding all of the zeros. So, with thanks to Sharktopus, who put up with being smushed aside with all the paperwork. I know, I got very excited. You got to understand, fractions, fractional zeros, very, very exciting. So go drink something calming, because the next couple videos are going to be very, very exciting, just like this one. And then meet back here, because you guys are brilliant, and you will hopefully have no trouble with the homework. But again, if you do, please ask me, ask the tutors, ask each other, and then let's go ahead and math on. Woohoo!